by the Science Guy.
The primary pigments are yellow, cyan, and magenta. When you mix magenta with yellow, you get red. When you mix cyan with magenta, you get blue. When you mix yellow with cyan, you get green. When you mix magenta, cyan, and yellow, you get black.
It's extremely important that he gets his first serve in here because... Oh, wait a second. There's some kind of disturbance behind the far line, Judge. No, it couldn't be.
It is, Lance. It's a crazy rainbow kid again.
White objects reflect all colors. Black objects absorb all colors. You know, he's right about that, Timmy.
He certainly is.
I love pigments.
I love pigments.
Three primary colors of light are green, red, and blue. When you mix green and blue, you get cyan. And then when you mix green and red, you get yellow. When you mix red and blue, you get magenta. When you mix all three, you get white. And when there's no color, you get black.
They're lined up to kick the extra point, and wait a minute. There's some kind of disturbance behind the end zone.
It's the rainbow kid, Lance. And as usual, he's holding up a sign.
White light is all the colors of light mixed together. You know, he's right about that, Timmy.
He certainly is, Lance.
Materials that are transparent, such as plastic wrap, let all light through. Materials that are translucent, such as wax paper, let some light through. Materials that are opaque, such as aluminum foil, let no light through. Polarized light is when light travels in one plane. When we use a polarizing film, only the light from the one plane is let through. There are sources of light that emit polarized light, such as computers and phone screens. For example, turn it. Ooh. Yeah. Polarizing films work because electrons move in the same direction and only lets light in through that plane.
The reason there was a change in sound was because the sound frequency changed, which changes the pitch. The source is what's making the sound, and the detector is what's hearing the sound. When the source and detector are moving towards each other, it's higher frequency, so it's higher pitch, and they're moving away from each other, it's a lower frequency or lower pitch. Talk to you later. Bye.
Consider the following.
The speed of sound travels differently through different objects. For example,
Sound travels the fastest through solids because the molecules are closer together and are more likely to bump into each other.
Sound travels slower through liquids because the molecules are farther apart.
Sound travels the slowest through gases because the molecules are furthest apart.
White light shown on red material absorbs green and blue and reflects red.
This car is red because it's reflecting red light. Now leave me alone.
White light shown on blue material reflects blue and absorbs green and red.
White light on a green surface reflects green and absorbs red and blue.
When red light is shown on blue material, we see black because no light is reflected, and all colors are absorbed. Green light shown on cyan material reflects green.
There's some kind of disturbance behind home plate.
It's that Rainbow Kid again, Lance. He's everywhere with those signs of his.
The color of an object is the color of the light it reflects. You know, he's right about that, Jimmy.
He certainly is, Lance.
When magenta light is shown on cyan, blue light is reflected and red light is absorbed. When cyan light is shown on yellow, green light is reflected and blue light is absorbed. When yellow and blue light are shown on a white surface, we see blue, red, and green, which is white light. When magenta and red are shown onto a white surface, we see red and blue, which is magenta.
Sound is created by vibrations that travel from the objects to set particles in motion. The particles move in the same direction as the wave because sound travels in a longitudinal wave.
This is an example of a longitudinal wave.
To see how fast it's vibrating, every time it comes up, I want everybody to say wub. So here, we're going to see how fast it goes. Everybody, when it comes up, say wub. Very good. You guys are very good wubbers. Let's try it again. Every time it comes up, say wub. So that's like a guitar string. It wubs or vibrates and it makes sound. So if I want to make a higher sound, I shorten the string. Now every time it comes up, say wub. Ready? It's wubbing faster, isn't it? Here, try it again. And that's what makes a higher pitch. When I make the string vibrate faster by shortening it, I get a higher sound.
This frequency is low, so the pitch is low, and the amplitude is low, so the volume is low. The frequency for this sound wave is high, so the pitch is high, and the amplitude is high, so the volume is loud.
When the light wave's amplitude is higher, the light is brighter. When the amplitude is lower, the light is dimmer. When the frequency is high, we see colors like violet. But as we go down the spectrum, the frequency becomes lower, and the lowest frequency is the color red. Light travels in a transverse wave like the girl in the front seat's arm.